Greetings to all my tech heads out there in the KevTechify nation, and if you're new here, welcome. In this episode, we're going to look at device security. We'll be discussing Cisco AutoSecure, passwords, additional password security, enabling SSH, and disabling unused services. This episode is part of my series on Introduction to Networks for the CCNA. I'm Kevin here at KevTechify. Let's get this adventure started. With Cisco devices, with the newer Cisco devices since version 12.2, we've had Cisco AutoSecure. Now, when you set up a Cisco device, it comes with a minimal level of security. Often this level of security is not adequate to protect your system, protect your network, to protect your resources. And so for Cisco routers, Cisco came up with this AutoSecure. Cisco AutoSecure is a simple script that asks some basic questions to help you secure your router. Cisco AutoSecure has four main functions. The first function is it disables the IP services that have vulnerabilities or that can be used as vulnerabilities against your system. The second item it does is it enables IP services that will help you stop attacks against your system. The third thing it does is it configures minimum password lengths and complexities for your router. And finally, the fourth thing Cisco AutoSecure does is it sets it up to generate logs when the maximum amount of failed login attempts have been reached. So it generates a system log to let you know that, hey, there's a bunch of failed logins. You probably need to look into that. In addition to Cisco AutoSecure, there are several measures you as the administrator should do. You should take default usernames and passwords and you should change those right away. If you can't change the default username, at least put a very, very complex password on there. A lot of times you can delete that default username. In some instances you can't, but what you need to do is make sure you remove all system resources that you can from those accounts you can't delete, and also just make sure they only have access to the resources they need. Also, unnecessary servers or services and applications, you should either turn them off or uninstall them, because if you leave them there, you leave them running, that's just another point or two that a threat actor could use to gain access to your system. And a lot of times when devices come new to you, they've been sitting in a warehouse for a while. They don't have the most up-to-date operating system. They don't have the up-to-date patches, upgrades in them. They have vulnerabilities out there. You need to make sure you stay up to date with your patches, with your updates, so that way that the problems that they've identified will be fixed with that. As you work with security, you need to look at passwords. Passwords are that main entry point to get into your system. If you think about that, just about every system you access, you have to enter in a username and a password. And so there are some things you should consider when setting up your passwords. You should look at the length of it. The book, the reading, it says you should use at least 8 characters, maybe 10. I'm hearing more and more companies requiring at least 12 characters in your password. At least 12 characters. And for sensitive accounts, sensitive data, I see that being pushed to 14, 16 characters minimum for your password. You need to make sure that they're complex. And by complex, we mean you have an uppercase letter, you have a lowercase letter, you have a number, you have a symbol, you have multiple of those, and that's required for those. You need to make sure you avoid the easily guessed passwords. Now, typically most systems won't allow you to have a password found in a normal dictionary. You have to have some sort of complexity built into it, but you should also avoid easy substitutions, where if you have the letter E, you put the number 3 in there. And so looking at that, you should use some logic in there. Now, you shouldn't change every E to a 3, What I like to do is change a couple of them. Maybe I have 2 E's in my password. I will change 1 to a 3 and I'll leave 1 the same. A good process for setting passwords is deliberately spelling something wrong. Here we give you the example that you could use. Say your password you want is Smith, capital S-M-I-T-H. You could spell it differently. You could go with a capital S-M-Y-T-H, a Y instead of an I. That would throw lots of confusion out there. Or you could change one of those letters into a number. You could go a number 5, M-Y-T-H. You could even change one of those into a capitalized letter. 5, lowercase m, uppercase y, lowercase t, lowercase h. Just making it more and more complex. Granted, Smith won't reach your length, but that it's an idea here. You should change your passwords often. Now, this is a double-edged sword. Changing your passwords often is a good thing, except when you do it too often. If you require your employees to change passwords every month or every 2 weeks, what's going to happen is your employees are going to forget what their passwords are. You're going to have little post-it notes on everybody's screen that says what their passwords are if you make them change it too often. If you don't change it often enough, if their account gets compromised, that threat actor will have access to your system for as long as that password's there. And so it's a balance here. And some of the things I've seen out in industry is how often to change your passwords. If you have access to privileged information, databases, personal information, HR, accounting information, you will change your password probably more often. If you're a normal shop user out on a shop floor and all you do is look up orders, maybe you will change your passwords less often. Typically, numbers I hear is if you're dealing with sensitive data, you're looking at 2 to 4 weeks rotating your passwords. Yes, I know it's a fairly quick turnover. You're going to wind up having post-it notes, but those people should understand they're dealing with sensitive data. Now, if you're not dealing with sensitive data, most companies go with 2 to 3 months for a password. Sometimes up to 6 months or a year, but you should at least have people rotate through their passwords. And you should never write passwords down. And yeah, it goes without saying, but you have to say it. You have to tell people not to write their passwords down. Don't put it on a post-it note. And if you do catch somebody writing their passwords down, and that's the only way they remember it, and they continue to do it, at a certain point, you're not going to fight with them anymore. What you could maybe do is suggest them, don't keep that post-it note out where everybody could see it. Put it on the bottom of your keyboard. Put it on the inside of a drawer. Hide that post-it note so you can find it easily, but the average person won't do that. And that's a worst case scenario, but it's a real world situation. One of the best things you can do with passwords is use a passphrase. If you have a password that needs to be 16 letters long, how are you going to do that? Maybe your favorite phrase is "I love rock and roll." You could use that as your password. Capital I, capitalize each word. Capital I, capital L, lowercase o, lowercase v, e, capital R. I forgot how to spell "I love rock and roll." And you could use that. Maybe you could change one of those letters into a number. Maybe you could change one of those letters into a symbol. And that would be your passphrase to get in there. Another way to use a passphrase is take a phrase and then use the first letter of every word. Let's take the phrase, "May the force be with you." Now, it's probably a little too short to get your length, but if you take the first letter of every word, M, T, F, B, W, Y, may the force be with you, that would be a phrase that would be a password that's really hard to guess. Capitalize the first word or the second word, put a symbol in there, put a number in there. You have a password that is very secure. And so passphrases help you set complicated, complex passwords. I hope you're liking this episode on device security. If you have the time, please leave a comment and let me know what you think about device security. You can also visit my website at KevTechify.com for all of my details and how to get these episodes in video and podcast form. There are some additional password securities you can set up on your Cisco devices. Here in this example, we have service password encryption. That's going to encrypt all of your plain text passwords in your running configuration. So if you type out show running config and you look at it, if you do the service password encryption, your passwords won't be in clear text. Your password won't be Cisco or class. It'll be a encrypted password at that point in time. We can set the minimum password length. That would use the security passwords minimum length command. And that you put a number there, and that's what the minimum length of your password is. Another one is to block attempts. And what this is here is we have the login command here, and we're going to block for 120 seconds. So this is 120 seconds. After 3 attempts, within 60 seconds. So in 60 seconds, if I have 3 failed attempts, we're going to block it for 120 seconds. We're going to block it for two minutes. Now what this does, this is pretty good for system administrators because you don't have to go back in and enable this account. What this does is after 2 minutes, they can try again. And so this will stop somebody from brute force attacking your system. But if somebody's legitimately trying to get into the system, they'll have to wait 2 minutes and then they can try again. Another one here is on our line configuration, we can use the exec timeout. And what this is here is that after you've had no activity in your privilege exec mode, it's going to log you out after a certain amount of time. And right here, it's going to be 30 seconds. It's going to log you out. And once again, we are using SSH instead of Telnet. SSH does encrypt all of our data. And so these are good security practices you should employ on your Cisco devices. Another item that's important to network security is enabling SSH. Now, when you connect in using your virtual terminal emulation, there's 2 protocols that are used. One is Telnet, one is SSH. Now, when we use our virtual terminal, this allows us to connect in over the network, to sit in our office, headphones on, feet up, listening to our music, and connect into a device to configure it, whether that device is in our office, across the hall, different building, across the city, across the country, or all the way around the world. If it's on the network, we can connect into it. Now, if it's on the network and we can connect into it, a threat actor could gain access to that. And so what you need to do is let's go, and we're talking about the communications that happen between our client and that device. We have 2 different technologies that are used. One is Telnet, one is SSH. Telnet is frowned upon in industry because any information sent between the client and that end device is sent in clear text. Meaning, if somebody was listening to your traffic and watching the information going across, they see every keystroke. And you type in the password, they will see exactly what your password is. It's sent in clear text. SSH is the bigger, better, more secure brother of Telnet. And what that does is between the client and that end device, it encrypts that traffic. So if somebody was looking at your traffic, they wouldn't see what your password is. They'd just see a bunch of random numbers and characters at that point in time. To set this up, there are several steps though to getting SSH working. First one is you need to configure a unique host name. On your network, there needs to be only one device with that host name. Second thing is you need to set a domain name up for your device. That is done here with the IP domain name command. You put your domain name in. Typically, it's part of a fully qualified domain name, cisco.com. A lot of times, I'll make a subdomain, call it network.cisco.com. And that would just basically identify anything that I'm using for SSH would be part of this network.cisco.com and not part of just the base cisco.com. Once you have that domain set, you go in and you have to generate your encryption key for your traffic. Now there's two commands. They're very similar, but yet a little bit different. On a router, we have the crypto key generate RSA general keys modulus bits. And so you go ahead, you enter in that information. On a switch, it's a little bit different. It's just the first 4 keywords, you hit enter, and then you specify the bit length. The bit length here, the default is 512. You don't want 512 being your bit length now for your key. That is pretty much universally accepted as insecure. It's too short of an encryption key. You want something longer. Plus, if you have 512-bit, you can't use SSH version 2. You only can use SSH version 1 because SSH version 2 needs a 124-bit length key. And so when they ask for your bit length, make sure you put in 1024 as your bit length. Once you generate your key, then you have to verify or create a local database entry. And what we're talking about is a user. You use the user command, you give it a name, a password on the system. And so that way when you do a show running config, you can see, hey, I have usernames and passwords set up on this system. Every user you want connecting into your system, set them up a new username and password. Then once you have those created on that local device, you need to tell it to use those local go back a couple words. You need to tell it to use those local credentials. And how you do that is instead of using the login command, you use login local. And that will use all these usernames you just created. Once you have all that up and running, SSH is configured. It's up and running. Now you just need to tell the virtual terminal emulator to use SSH as the input. And so down here, you need to go into your line VTY04 or 015 and put transport input and then SSH. And that sets it up to use SSH. It forces it to use SSH, forces the system to use that encrypted traffic. On a final note about securing your system to prevent network attacks is to disable your unused services. Now, a lot of times you'll have web servers running, you'll have other processes running, not only on your Cisco networking devices, but on your servers on your network. Windows, Linux, they all have services you're not using. And if you leave those running, they're going to use resources, they're going to use processors, they're going to use RAM, they're going to use hard disks, they're going to slow your response down, but also they're going to give avenues for different people to use to attack your system. If you use the web server on your Cisco devices, for a while there was a problem where you could enter in a URL that had some special coding in it that would go and change the privilege exec password. And you could change it to what you wanted, and then you had access to the system and you locked out everybody else. Now, a lot of these services are turned on by default, so what you have to do is you have to go in there and turn that off. And for Cisco's systems, that Cisco AutoSecure feature, that helps you do that quite a bit. So make sure you disable your unused services. It was my pleasure to provide you with this wonderful episode on device security. If you like this episode and you got value out of it, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All my socials and contact information are on my website, KevTechify.com. There you can find out how to get all these episodes in video and podcast form. In the upper right is my playlist for my series on Introduction to Networks for the CCNA. In the bottom right is one of my favorite videos that I linked just for you. Thank you so much for watching this episode of my series on Introduction to Networks for the CCNA. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.